This is an example of if you were to see something called a two-column proof. So for pretty much the rest of geometry, these proofs are fair game. And sometimes you're going to be given the proof where this entire left side of the statements is available to you and you're going to have to fill in the reasons. Sometimes you're going to have to fill in some of the statements and you'll have some of the reasons and you'll have to fill in some of the other reasons. And then there may be a situation where you're just given this part here and you have to construct the entire proof by yourself, which is going to entail some thinking on the side of the left here, but also then relying on what you know about geometry and all the postulates, the definitions, and the reasons that we're allowed to use, the properties, relying on the fact that you have access to all this information and understanding that if you're given the beginning, so we're given the first part and we're supposed to be proving the answer, you're given the answer. So you know where you're supposed to be going and you're going to use your postulates, proofs, and theorems to help you get from beginning to end using deductive reasoning. So here we are given that this expression exists and we're given that here in step number 1. And we're also then reminded that A equals 7, B equals 3, and C equals 2. And you'll see that we're supposed to be proving that this expression is evaluating to equal 7. And so we will eventually do that. But the first 2 steps here are given to us in the problem, so we are able to label them given. And then we look and we see, okay, well, if A equals 7 and someone put a 7 here instead of A, B equals 3, so someone took out the B and put 3 in, and then we took out the C and we put in a 2 instead, so that's substitution. And then everything you kind of think of in terms of evaluating or doing math, just doing arithmetic, is going to be considered substitution. So here we have 3 squared is equal to 9. So we're going to be considering that substitution as well. Here we have 9 minus 9, or 9 plus negative 9, which is equal to 0. We're going to be considering that the inverse property, because 9 plus negative 9 is equal to 0. And then we know here that 8 times 0 is equal to 0, so that's the 0 property. This is always just true for multiplication, so you don't really have to put that. And then 7 plus negative 0, or 7 minus 0, is equal to 7. So then we know the number keeps its identity, because we're just adding or subtracting 0. And then we are finished there. And that is an example of one thing that you'll have to do, evaluating expressions given a property for each of the steps.